In lesson 3, angle side angle proofs, we're going to first start by looking at a couple triangles, and we're going to identify the missing set of corresponding sides that would need to be congruent in order for angle side angle congruence, and then we want to state our congruency statement. So if we look here, in part A we have angle, 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 angle. So remember, order is important here, and that side must be sandwiched in between those two angles. So in order for this to be true, we'd have to have KL is congruent to UT. And then if we wanted to make our triangle congruency statement, you can pick however you want to start in the first triangle. So I'm going to go KLM is congruent to, so notice I went from one congruent angle to two congruent angle to the blank one. So therefore I have to go from U to T to S in the second one to make sure that my corresponding angles match up correctly. In part B, we have our vertical angles in the middle, so we're going to want to label those. And then that would label WV and KV as our congruent sides. So we would need angle WVU to be congruent to angle KVU. Again, you might be able to do this as well. I didn't put them in my picture, but you could use angle 1 and angle 2 if you label it. And then we would need WV to be congruent to KV in order to jam those sides in between. So our triangle congruency statement is, again, I'm going to start WVU. So I went from 1 to 2 to blank. So in the other triangle, I have to go from K to V to M, 1 to 2 to blank. Now we're going to actually do a formal proof here. So they give us some information. QP bisects angle NPM, and then QP is perpendicular to MN. So we have to remember we're cutting an angle in half here, and then also perpendicular is going to be a two-step part. So QP bisects angle NPM, and QP is perpendicular to MN, and that's going to be our givens. So let's look at the bisects piece first. So QP bisects angle NPM, which means we have these two angles, and I'm going to label them 1 and 2, that are congruent. Notice it says it bisects the angle. Sometimes people think that, oh, well, Q must be the midpoint, it cuts that in half too. It doesn't say that. So therefore, you are not allowed to say that. You can only write and talk about the things that you know are true. And since the only thing it told us is that the angle gets cut in half, that's the only thing we're going to write about. So in step 2, angle 1 is congruent to angle 2. A bisector divides an angle into two congruent angles. So there's going to be our bisector definition. So now we're done with that piece. The next part is if QP is perpendicular to MN, that's going to give us two right angles there. We'll call them 3 and 4. So remember, perpendicular takes 2 steps. So for step 3, we're going to write angle 3 and angle 4 are right angles. And the reason for that is going to be perpendicular lines form right angles. And then since we know all right angles are 90 degrees, we know that they're all congruent. So angle 3 is congruent to angle 4. All right angles are congruent. So what does that give us so far? So we got an angle here from our bisect. We got an angle here from our perpendicular lines. And now we're out of givens. So therefore, we're either reflexive or vertical. And I see a reflexive side, QP. So QP is going to be congruent to QP. Reflexive property of congruence. And now what does that give us here? That's a side for us. So we have angle, side, angle, an angle side angle. So in step 6, triangle PNQ is congruent to triangle PMQ, and our last piece is going to be angle side angle.